Let's see how we can find the integration of this multiplication of these two functions, ex and sin x. In this case, we can use the theory of this integration by parts, and I will recall what was that. So then if we have a multiplication of these two functions, one is in the form of differentiation, another one is just a function, and both these u and v are the functions that were written in the variable x, right? So, and we can write for this integration, we can write the multiplication of these each function, which one is in the differentiation and which one is the out of differentiation, minus, and the integration of the function which was not differentiated at the beginning, it means the function u, and we can keep the function v which was in the differentiation on the left hand side, right? And now we have to decide which function going to be in the form of differentiation. That's the most important thing. In this case, that doesn't matter which function we're gonna write in the form of differentiation. At the end, you will understand why that I said that doesn't matter, that which one gonna be the form of differentiation. In here, for the ease of simplification, I can take this ex in the form of differentiation because that's the most simplest thing. Right here, I can write, the color is not that visible, let's get another color, black. And here I can write down for this ex the differentiation of ex, because we know what is the answer that this differentiation of ex gives is the same ex, that is not getting changed, right? And we can keep sin x out of the differentiation here. Now we have a multiplication, one is a differentiation, another one is just a function, and both of them have the same variable x, right? So here now we can follow the theory of integration by parts, and now we can write down the multiplication of each function, which one is in the differentiation and which one is the out of differentiation, and ex times sin x, right, minus, and we can keep ex, and now we have differentiate function sin x, right? So what is the answer of the differentiation of sin x? As we know, that is the cos x, and here we can write down ex and sin x, ex times sin x. And again, we have something that we can't sort out. It means this is a place kind of that we being helpless, because even we don't know how to get a straight answer for this multiplication of the integration. Right, so then it means that we have to use this integration by parts again. Even for this expression of this integration, we can write the form of that integration by parts. It means for the ex, we can write the differentiation of ex again, and we can keep cos x outside, right? So for this expression, for this term, we can use that integration by part. So again, we can write ex times cos x minus an integration, and we have to keep this ex out of the differentiation inside this integration. It means this one was not differentiate, so then we have to differentiate this one now. In this way, right? So now we can expand this bracket and multiply by this minus, and minus ex dot cos x, and don't forget that always this part of the answer was before this part, right? Ex times sin x, ex times sin x, ex times sin x, right? And we can multiply this minus by this minus, then answer will be positive. And ex, and what is the answer of the differentiation of cos x? As we know, that would be minus sin x, right? So plus ex times minus sin x, the sign of this whole expression would be minus, then we can get that minus out of this integration, and we can keep positive for the terms inside the integration, right? This is the final expression we can get, right? At this case, usually students forget what was on the left hand side. That was what we started to integrate. That was the integration of ex times sin x, right? If we want, we can see this whole term of integration of ex times sin x as a single constant. In fact, that is not a constant. I just wrote the term a, right? So then you can see at the end of this simplification, you have this expression. You need to change color, and ex sin x, ex cos x. If you want, you can make these two factorize, because you can get ex out of the brackets here, and minus a. This a is not a constant. This is another word, another term you can call for this integration. So what I want to do is, I want you to see you can simplify, and you can move this minus a to the left hand side, and its sign will be positive. It means you can have a plus a on the left hand side. That's what I want you to see here, right? In this way, you can isolate a on left hand side, and a is something that we're looking for the answer. Then we can divide both sides by 2, and what is the expression behind a? That was the integration of ex times sin x dx, and half times ex sin x minus cos x. Then would I say this is the final answer, or do we have make any mistakes? Yes, we did a mistake. That is that we forget to add a constant at the end of the answer, because this integration part, what we did, belongs to the undefined integrals. Then at the end of all the undefined integrals, we should add a constant for the final answer, and we should define that was an arbitrary constant, and we can write down C is an arbitrary constant. Otherwise you will not get the full marks for this. That's how you can integrate.